Hi, we're back with the series where we're covering how to prepare for code interviews as well as perform a code interview. It's my continuing thing. I stress this every single time. It's my opinion that code interviews are about the conversation and they're not about successfully completing the problem. You want to structure how you perform during this. It's not a test of what you know, right? If that were the case, it's really going to boil down to kind of luck, whether or not you have studied the right stuff, whether you took the right classes in college, whether you learned from the right mentors. Nobody really cares about whether or not you get the problem correct with no help and no guidance. And in fact, I would argue that's not even to your benefit. It's not always to your credit to be perfect at doing the code problem. That just means they didn't select a code problem that really pushed you to your limits. If anything, it's more of a knock against the interviewer than it is against you as the candidate. So it's really about the conversation and not really, it's not so much about building rapport. It's not about being charming. It's about having this sort of central artifact, the code, being the basis and anchor for the conversation. And so it's how do we code so that we can have that conversation in the actual text on the screen and not vague hand-waving shenanigans. It's not asking questions without any context. It's about really having the context and saying, okay, hey, it matters to me what this variable is, what the bounds are, what the constraints are for this. How many times are we, how big is the array size? What are the actual values in the array? Sometimes that matter, sometimes it doesn't. So my claim is you want to build towards that conversation, not just build towards the magic of being able to classify everything as a particular sort of problem. You shouldn't necessarily go into it knowing the full context for when breadth first versus depth search. Like that's not the thing that matters. The thing that matters is the conversation. This is my claim. This is what we're going to practice, and hopefully what I'm going to demonstrate for you here today. There have been a few comments, a little bit of feedback on the past videos. One of them was that the text was too small, so I'm trying to zoom in, and hopefully this is going to be a little bit better for viewing and also potentially for following along in the code. The other thing was, hey, what if we don't have the ability to turn on asserts? In all the other videos that I've done up to now, I've used assert, the Java keyword, to do some, rudimentary unit testing. What do we do if we don't have assert? So we're going to cover that today. And then the last thing, I really want to zero in a little bit more. If you have watched any of the other videos, then this will not be a shock to you. I have this same set of 4 criteria. Sometimes I'll change it, use different language so that hopefully it'll resonate, at least one time it'll resonate with you. But it works like this. The first thing that we want to do in the interview, the first thing that we want to do in the preparation is to write out what the signature is. Another way of looking at this is the public exposure, or the interface, not the Java keyword interface, but the application interface. It all sort of boils down to what is it that they're asking. You want to as quickly and cleanly and tersely express that in code as possible. You want to really capture what you're being asked to do, and that way you can keep referring back to it, that sort of public exposure, that public interface for how your particular solution is going to be used by a hypothetical person. The next thing you want to do is write the test, write the exercise. In fact, I'll write it this way: exercise, the signature. So it's not just enough to say, how will people call this? What's the public interface? Show how people will use that signature, will use that interface to solve the problem that this thing supposedly solves, right? So if you're writing this hypothetical solution and the hypothetical user knows what the public signature is, how do they interact with that public signature to get the result that you're claiming to deliver? Again, we're gonna go a little bit more into this. I just want to really make sure that we absolutely drill down. The next thing that we want to do is show progress. Show consistent progress, if I could spell. I want to be very clear about this. In my opinion, what I am saying when I am saying this is red, refactor, green. You want to show passing tests in whatever context you're in whatever way you can. It may literally just be you sort of walking through the code saying what gets passed around, what's happening in each thing, and you literally executing the code by hand. I have done that before in interviews. You want to show this idea of, I did some work, I can see what the output is. Oh, I now see when I look at the output this way, there's this edge case I hadn't considered. And the point is to continually make progress on the code you're doing, even if that progress is slim, right? Even if you're not making a lot of progress, you want to show progress. Again, we'll dive into that here. We'll talk about it a little bit more. The last thing is be opinionated. Now, this is the one I haven't really focused on. Opinionated. There we go. I haven't really focused in on this too much. It comes out a little bit because I am a ridiculous human being and there's no way I won't be opinionated in a given 30 to 40 to hour long discussion. But I want, again, I'll try and drill in a little bit more on what I mean when we're talking about be opinionated. Again, I can't stress this enough. If you're having a conversation with someone and the only thing they can say when they walk away is, well, they did the problem. They deliver the solution. Like they're just not engaging to a hiring manager. They need some way to remember you. Even if it's ridiculous, even if it doesn't make sense. They'll ask you about it if they think it's so controversial, but you still did all the other things, right? In other words, if you say something ridiculous, what are some things I've said? If you say exceptions are for control flow, a lot of people are going to be like, what is wrong with you? Hey, and then you walk through, look, that's exactly what they are. Whether you use them for control flow or not is up to you. But they exist for control flow. And you want to be conscious of the fact that they will break your flow of control if you aren't paying attention to them. I think that's a much healthier way to look at exceptions. It's amazing to me how much I have fought with people over the years over whether or not that's true. And it's okay to be that kind of opinionated is my point. I've never not gotten hired because I'm a ridiculous human being when it comes to exceptions. I'm sure I've been not hired for other reasons. Not being a ridiculous human being. But the point is, being that kind of opinionated means that you have this way of sticking in their heads. They can say, oh yeah, that guy who's crazy about exceptions. I mean, if we hire him, we got to there's going to be some hard code reviews for a while until we can trust him. And the reality is, if you can provide that kind of context, if you can provide that kind of memorable experience in that 40 to 50 minutes, if you can be memorable, you are well on your way to landing a job. In other words, being opinionated, I've talked to so many people who are afraid of their personality coming out specifically around code. They're afraid that they'll be seen as someone who can't code the way everybody else does. They're really concerned about their code. And so they'll do things in their code they would never do. Like write the most absurd comments I've ever seen, thinking that that's the sort of thing that an interviewer will be looking for is comments. It's okay to be opinionated. If you feel strongly about comments, absolutely put them in your interview. But don't try to fake it and just write whatever you think they want to hear or whatever they want to see. Right? That's not how this works. It's not that kind of conversation. You're trying to show people who you are. And you shouldn't be afraid of who you are, controversial opinions included. Okay, let's dive in a little bit more. what we've got. Oh, I'm sorry. We haven't even read the problem. Again, I am pulling these from linked code or from LeetCode. I think LeetCode is a fantastic resource. I think it's a great way to practice a lot of these problems. These are the sorts of problems that will show up in code interviews in lots of different places. I think it's useful I think it's just useful practice. I think it's useful context. I'm not sponsored by them. I can't imagine a world where I would be. I'm trying to not use their problems directly. I'm also not using their interface. Hopefully this isn't bad. I do want everyone to know where I'm pulling it from, what the original problem is. This one got clipped off a little bit. It's problem 785 on that long. The link will show up in the notes at the bottom of the video. All right, so given the heads of two singly linked lists, we want to return the earliest node shared by both lists, or null if the lists share no nodes. So what do we mean here when we're talking about sharing nodes? If you look at this example, we have A, B, and C, and then this little slash is trying to point you down to G. So the first list is A, B, C, G, H, I. The next list is D, E, F, G, H, I. And we're supposed to return the node that's shared, the node that is in common, the instance that is in common to both of these lists. So here we have this note, C and F point to the same instance of node G. In other words, if instead of being F, this were C, but it's a different C node than this C node, in other words, it doesn't matter that the values are the same. It matters that the instance that is the node is the same. If that's shared between two lists, then that's the node we return. And again, we want to return the first one that's shared, so we wouldn't want to return H or I, even those are also shared. We want to return G. All right. Now, before we dive too far into this, unfortunately, it took me long enough to write all this up that sadly, I think I know a really good way to solve this. I want this to be the sort of thing where you can see me solving it real time, but again, there's just enough time behind the scenes where it would be disingenuous to tell you I'm coming up with these solutions on the fly. So I'm going to do the solution that I think is sort of the obvious one first, and then we'll sort of unpack. They have a follow-up question, and we'll unpack the follow-up question. All right, so again, my first claim is write the signature. So what does it look like to do this operation? They're asking you to do something. How would someone use what you do? So we're trying to say public it'll be some node intersection node list 1 node list 2. All right, right now we'll just return list 1. And now let's talk about what this class is going to be. So public static class node. In fact, this is where I told you to be opinionated. This is where my opinionatedness is going to come out. If you're going to do some of these inner classes, my claim is you want to try and make these things as final as you can all the way around. Final doesn't mean enough to really kind of care. In Java, all it's really saying is don't extend this. I mean, you can argue it's doing slightly more than that, but the point is, I think you should try to restrict this down kind of as much as you can. I also feel that having public members is fine. Doesn't bother me in the slightest. So this is a singly linked list. I want to mention, this was some feedback I also got. I want to mention I can't imagine a world where someone will ask you a question about linked lists for a programming interview, and they want you to use Java util linked list. I'm sure it's possible. I'm sure someone can come up with a problem. I just can't. I mean, maybe if I thought long, but my point is, if someone's asking you a linked list problem and they're being, sort of directly open about singly linked lists, they want you to write a node class. If they don't give you one, just by default. All right. The next piece of this is, if you don't have a good reason to, I strongly always, every time, recommend making these things final. And so we're going to want to have two constructors. I am sometimes asked in interviews why I am willing to always use the same things. I believe very strongly that you should always use this inside of classes. Anytime you have a value, in other words, you wouldn't need to do this. If you call this like underscore value, you could just say value equals underscore value. But I think this is the right way to do it. I can argue and defend that, but again, that's not what this question's asking. It's not asking argue and defend that. But when you have final things like this, it doesn't bother me that the members themselves are exposed. If they're final, they can't be changed by someone else. They can be viewed by someone else. I don't see the point of having a constructor or the point of having a getter for a final member. Now, there are times when I do see the point of doing it, but if there's no interface going on, if this guy's going to be final, yeah, I don't know that that I would ever do that. I also do my best to only have one constructor that matters, and everybody else call that constructor. I don't remember this behavior. I don't think this is Java related. I can't remember what language this came from, where I try to always have a primary constructor. It might have even been C or C++. Anyway, point is, I've always done this, and that one I can't tell you why. Okay, so we have our class node here, and we want to set. So that's our first thing, right? The first thing we did was write the signature. Our signature is the combination of this interface and this class. These are the things we were asked to provide, because we were asked to have an input of two linked lists, and we want to find where they share stuff. This is where they share stuff. This is our definition for the linked list. So this is sort of satisfied this first bullet point. And you'll notice along the way, it's not that you're necessarily having to do these in order. Along the way, we were opinionated. We used finals all over the place. All right. When we have we're now going to use our main method to exercise the signature, but we don't want to do asserts. We don't want to use the assert keyword. Remember, if you do use the assert keyword, you have to be able to turn it on with a -ea, it means enable assertions. In the you have to be able to pass that as a VMArg. And you might not be able to pass that as a VMArg depending on the environment. Now you could just create a static method, public void test. Here it'll be node actual node expected string message. And then if actual is not equal expected. And here we can actually cheat and say, because we're returning the actual node, right? Because remember, this wanted us to return this G node. We know the actual instance. And so we don't even need to do dot equals. We can literally say, if this object is not the exact object you're asking for, it was the wrong object. So if it's not the right object, throw new assertion error. Really? It doesn't have just message? Yeah, it does. Okay, there we go. We may decide to go put in and then all I did here is just implement the keyword assert. That's all. right? This isn't magic. You can just implement the keyword assert if you don't want to go use -ea. But that's probably not what my friend was asking me to do. He wasn't asking, can you go implement assert for me? It's more of a, hey, are there other ways to exercise this? And of course there are. Of course there are other ways to exercise this. So one thing we could do is to come up with a compelling toString. So we're going to do toString. I always forget to do it this way. So instead of doing that, you can right click and do source action, I think, and generate toString. We want to include the value in next. That sounds good. But the way that we want to include the value in next is not like this. So we want to return value plus, we're going to do the little arrow like we did in the, oops, and then plus next. Now, remember what I said, I prefer to always, always, always add in this. The number of times that that's saved me from being an idiot is, well, probably not enough. It probably hasn't saved me from being an idiot enough times. But the number of times this behavior has helped me is just been invaluable to me. I think it's much more readable. It's a lot easier to maintain coming back in the future, especially if everyone is on board. All right, so this is going to be our toString. It should look very similar to what we had up here, except it'll do A, B, C, arrow G, arrow H, arrow I. Right? It won't be able to show the joins this way. But this should return a toString that we're looking for. So the next piece of this is we probably want a simpler way to make nodes. And given this, my suspicion, how are we going to do that? My suspicion is we should have a factory method that takes a tail that might be null and a list of strings that it's going to turn into the head. And so then we'll do node head equal, or values. There we go. Node head equals new node. We need to pass it. We'll do value sub 0. And then for int I equals 1, I less than values.length, I plus plus, we're just going to, let's see, we also want a node current, which equals head. And so then we want current dot value, current dot next equals, oh sure, we're not going to be able to just set that, are we? Okay, well, let's be silly. Return. So if values.length equals 0, return tail. Otherwise, return n new node value sub 0 comma n tail yeah, there isn't a slice in Java. So what I'd like to do here is get the set, or the array that is values starting at 1. And so instead of doing this, we're going to do public static node n node tail comma string values. We're going to return n tail comma 0 comma values. And here we're going to have int offset. If offset equals values.length, then we return tail. Otherwise, we return this offset plus 1 value sub offset. Oops, put that in the wrong place. And tail offset plus 1 values. Whoops. Semicolon. Yeah. So what's happening here? Why did I do this recursive? I'm mostly doing it recursive because I'm being silly. I wanted to have a nice way of creating this, and this is probably the wrong way to do it. We're in the middle of an interview. You know what? Instead of doing this recursive shenanigans and this being the confusing part, we're not going to do this. We are just going to have string value node next. And we're just going to mimic our constructors. And this is just to help us. And so this will just be string value. And we'll return a new node that is just value. Okay. So the thing that was there before, is that the sort of thing I would do in real life? Honestly, it might be. It is an unfortunate consequence of this industry that we have to make things more exciting than they are. And that is really the root of all evil in programming. In other words, we oftentimes will solve problems in ways that they didn't need to be solved because it makes the code more exciting or more interesting to us. And that is probably a shame. Okay, so how are we going to use this new way of testing things? What we want to do is, so we want to do shared. And that is going to be node of G, comma, node of H, comma, node of I. So remember in our test case, that's our, oh, I see it. I put those inside the node class, so we would have to do node dot to reference them. Just for the sake of keeping the code simple, we'll do it this way. So a lot of times I do put builder methods inside of classes, especially when things wind up being final. Yeah. And to be honest, I might not even use the constructors this way, but whatever, we'll keep going. So that's our node shared. Node list1 is going to be n of A, comma, n B, comma, n C, and C is pointing to shared. Node list 2 is going to be, what did we say it was? I think it was it DEF? Is that our, yeah, DEF. D, and comma E, and comma F, and then this is again pointing to shared. Okay, and then our claim is that node result equals the intersection of list 1 and list 2. Oh, we have to actually have an instance of this. So I do feel pretty strong. I do think naming a class solution 5. I'm just doing this so that I can keep track of them for YouTube posting. Yeah, this is pretty crappy naming structure all by itself. But I also think that the signature in this particular instance, I personally wouldn't make it static, even though there's no reason to not make it static in this context. Just normally, public exposures, in my opinion, shouldn't be static unless there's something straightforward like a factory method. It just means the big problem with it is that static methods that do arbitrary things, it's not always clear that they didn't create something, they didn't store something behind the scenes. Singletons are the one exception for that, maybe. I can buy that there might be some others. Maybe if you made your own flyway instead of using an enum, something like that, or flyweight. But yeah, in general, I would steer clear of trying to use static for something that you expect other people to use. All right. Well, that does arbitrary work. All right. So whatever this thing does is going to return result. And so my claim is we can use just straight old system.out.println. I do think using something more interesting is probably in everyone's best interest, but whoops. Like, in other words, trying to do some sort of formatted message. That's the problem is, you're in an interview context. There, you don't necessarily want to get bogged down by doing clever things. You want to keep things sort of as simple as you can. So we have a simple way of building up our test case, a simple way of executing it, a simple way of seeing the result is what we wanted. And it's not what we wanted because we're returning list one. Now, I do want to point out, this is generally the sort of thing I do in an interview. I haven't even started solving the problem. Do you see what I'm trying to get at? By writing the signature and exercising the signature, we have a lot of context here to talk about the problem. Hey, if I'm going to be iterating over this stuff, I know now at some point I got to iterate over most of list one. Worst case, if they never intersect, I got to go through all of list one and all of list two to figure that out. How big are these lists going to be? If I do something recursive, is it going to blow out the stack? You get to ask really interesting questions. Do these values, I made them strings. Does it matter, to the context of this? Do I need to be worried about what these values are? Do I need to have clever ways of unloading the memory for them or something like that? And the answer is no. We're not going to do anything that messes with these two lists. They need to stay exactly the way they are. The real thing is about returning the actual instance. Remember that the exact object that is shared. So it's not even that we want these strings to be the same. We want this object instance to be this object instance. Okay. All right, so here we go. Here's how we're solving it. There are lots of ways to do this. Maybe an obvious one to you is say we're going to create a set node. Nodes equals new hash set. Let's go ahead and organize our, whoops. Man, why can't I remember? It's dot. That's what it is here. Add all missing imports. Yeah, and we haven't used nodes yet. So now we're just going to loop over list one and shove them all in nodes. So for or while, let's see, node current equals list one. While current is not null. Nodes dot add current equals current.next. So we're just going to iterate over our list, shove them into nodes, and then node cur Or here, we'll just reuse the same one. Cur equals list2. While cur does not equal null. In fact, let's do this. And cur, let's see, nodes contains cur. Cur equals cur.next. And then whatever cur is, that's what we return. So why is this the way that, like, why do we expect this to work? We're doing a contains, but on an object that it doesn't even have a hash code. Well, I mean, it does have a hash code. It does have an equals by default, and its equals is object identity, right? The instance itself. And so we're checking, do we actually have that physical instance in our hash set? If the answer is yes, we stop looping because cur is the thing we want and we return it. Otherwise, current's going to wind up being null. We return null. So now we run it, and sure enough, we get that they're the same thing. Just to make ourselves feel better, we're going to actually do result equals shared. I can't remember. In Java, do we have a triple equals? Yeah, didn't think so. Okay. And we get true. We are returning the exact same instance that was shared. So now let's see. We can now mess around with our shared and list1 and list2 to see if there's anything else we need to worry about. One of the things I'm curious about is what happens if they're different lengths. So let's just hack D out of the equation and make sure that that still works. Sure enough, it does. Another thing that might be weird is what happens if they're the same value. I mean, we're never checking values, but it might be nice to check that. We're never checking values, and sure enough, that comes across the same. So it's not just the fact that at some point they have the same value. It's that they have the same exact instance, which is what we expected. Cool. So as far as I'm concerned, we have done the thing that we were asked to do. But we've done the thing we were asked to do by effectively doubling, however big this list is, we now have to maintain a hash set that is that big. Is that a problem? Depends on how big that list is. And honestly, it's less about is that a problem and more about, hey, can we do better? What would better mean in this context? Right? So we're looping, if you look at this, we are looping over list 1 and looping over list 2. So our runtime, if list 1 is size m and list 2 is size n, our runtime is order m plus n, because we're doing a loop over the first and a loop over the second. And so the question is, can we keep the same runtime, but get rid of this shenanigans in terms of space? And again, this is the thing where it would have been nice if I hadn't, sadly, I can't turn my brain off while I'm trying to write the problem. I say sadly. Is that the sort of thing humans should be able? Anyway, it doesn't matter. The point is, I already thought about the solution, and I apologize. I don't know how I could do better by not thinking, but I'll try. I'm sorry, but I already thought of a way to do this. So again, the question is, can we not have this set, but still have order m plus n runtime? Well, let's think about what's really happening here. At some point, if these two lists intersect, at some point, they end. And if they intersect, they end on the same node. Right? So if they intersect, they share their common last node. Now, they might share nodes before that. In other words, the last node isn't the thing we're necessarily returning. But the point is, they share the last node. So if we knew up front how long these two lists were, like say we know that the first list is 20 elements and the second list is 10 elements. Cool. Throw away the first 10 elements. They couldn't possibly matter. throw away the first 10 elements of the first list. So now we're left with 10 elements in list 1 and 10 elements in list 2. Cool. Now, just iterate over those two lists until you find the same instance and return it. Does that make sense? In other words, once these are the same length, you just iterate and check. Is AD? No. Is BE? No. Is CF? No. Is GG? Yep. Return it. So the question is, if we loop over the two, we don't know how long they are, right? That length is not something you get for free from a linked list. You have to iterate over the two lists. Okay. Well, I can figure out the length. I can iterate over the first list. That's order M. I can iterate over the second list. That's order N. Iterating over both of them together that way is order M plus N. Okay, now I have the length of both lists. And now I can throw away some amount and then iterate over what's left. That is an order of whatever the maximum of M and N are, which is less than the order of M plus N. So it's still order M plus N. So the point is, can we do this? Yeah, it winds up being probably just as simple as this was. All right, so the first thing we'll do is we're going to implement a function called len. So int len1 is going to equal len of list1. Len2 is going to equal len of list2. And now we have a lot of leeway, right? Because these two lengths are what we're trying to do, right? Or these two lengths are the thing we're trying to sort of iterate over. So now we do need a cur1 and a cur2. So the question is, how do we loop over this? How do we loop over these two things to sort of skip the whichever list we need to skip in to get to the value to get to the ones where they could start being the same, right? So the first thing we need to do is throw away. The second thing we need to do is iterate and compare. Right? Cool. So how are we going to do the throwaway part? I'm just going to delete all of this for right now. How are we going to do the throwaway part? My claim would be that the easy way to do this is to write another method. So if len1 is greater than len2, so what does it mean if length 1, so list 1 has more elements than list 2? That means we want to throw away. Let's make that a capital A. Okay, throw away from list 1 len1 minus len2 elements. Right? Else, we want to throw away from list 2 len2 minus len1. Now, this could be 0, right, if they're equal, but that's fine. And my claim is we will bump these two dudes to here. And then we'll say list 1. You know what? This does get back to one of those things I do feel pretty strongly about. I hate assigning to arguments, so we're not going to do that. Cur2 is going to equal list 2. So list 1 will still be whatever it was if we wind up throwing away from list 2. Cur2, in other words, cur2 will change if we throw away from list 2. Cur1 will change if we throw away from list 1. And the other one will stay the same. And now these two things will be the same. And then we know that while cur1 is not null, because they'll both be null at the same time, In fact, oh no, they'll be null at the same time. While cur1 does not equal cur2. Cur1 equals cur1.next. Cur2 equals cur2.next. Return cur1. So one of two things will happen. Either at some point they'll match up, this loop will break and we'll return it because they're the same, they're equal. Or they'll be equal when they get null equaling null and we'll return null. Okay. So we need to implement two things. The first one is len, the second one is throw away. Public int len node list, and the length of a list is going to be int result equals 0 while, oh, we need a cur. Excuse me. While cur is not equal to null, we want to add one to result, so result plus plus cur equals cur.next. Now, there's all sorts of things. Couldn't we do this in a for loop? Absolutely could. Does it look better in a for loop? Absolutely does look better, right? Here's what I mean by that. For node cur equals list, cur does not equal null, cur equals cur.next, right? This is now the same. Oops. This has the exact same behavior as that while loop. So why do I do the while loop? And a lot of that boils down to writing your own linked list stuff gets really hairy really quick, especially once the nodes start having different pointers in them and you start trying to track different stuff that can happen in lots of different ways. Sometimes you want to loop over, you want to do every other current, you want to do all sorts of crazy stuff. This only looks pretty for the most basic way of iterating over a linked list. Any other linked list iteration, you're going to want to use, in my opinion, you're going to want to use that the while loop structure. And you'll notice that back before when we had it down here, the while loops aren't always the obvious thing of cur not equal null. And so because of that, I personally just always do the while loop. I think it's much easier to read. I think it puts the sort of focus on the inequality. It makes it sort of, it's not in the middle of a line, buried in the middle of two semicolons in a for loop. It's sort of front and center in the while loop. I personally prefer doing it this way, but to be frank, I don't like writing custom linked lists. I think this sort of behavior is kind of fraught with problems, and the only reason I'm doing it is because it's in the exercise. So here we go. This is how we're going to compute the length, and then public int or node throwaway node list int count. For int I equals 0, really 0, I is less than count, I plus plus, node cur equals list, cur equals cur.next, return cur. So we just implemented len, we just implemented throwaway. Both of those are order whatever list was passed in. So this is order M, this is order N. This would be order at most M, this would be order at most N. And this would be at most the delta of or the lesser of m and n. So all of this together is order m plus n, and that will be, hopefully, the result. And it came out the same here, but this was sort of the, oh no, this was the good one, right? Yeah, we have two different length lists. I am curious what happens if we don't have a shared thing. We haven't really tested that. So this was no shared anythings. So this was null and null, or this returned null. Shared, our printouts weren't helpful anymore, right? Because we don't have anything shared. So our result should not have returned the shared value because shared isn't shared. And so these things should not have been equal because result should be null, which it was. Cool. All right, so there we go. We've now successfully done another one. We have implemented our 4 bullet points without using the keyword assert. So good on us. Whoops, excuse me. Let's clear out my. Why can't I ever remove unused? There we go. Yeah, it's funny. I haven't done a lot of Java programming in the last several years, and when I did do Java programming pretty heavily, I preferred using Eclipse. So it is a little weird trying to get used to a new IDE while teaching people how to interview, but I think that makes it even more fun. So, yeah, hopefully this was useful. I hope to continue doing more of these as people show interest. So please do share your feedback and let me know what I can do to improve. Thanks again for joining, and see you next time.